Here's what's going on behind the scenes. This project started with a simple idea. I wanted my AI to live inside my system, not just a chat in a window. So, task 1. We need an AI assistant. So I started by connecting multiple AIs together, forming a complex system. My laptop runs a large language model that is basically like a brain, using Gemini and a few custom models that I've trained myself. Then I use LiveKit, which basically lets the AI talk in real time. That's how my agent hears me and speaks back instantly. Task 2 is to make the system control real world without exploding, burning me or the house. So I connected a RaspberryPi with its own camera to act as an external sensor and controller. It sends real-time video back to my PC, then the AI analyzes it using real-time custom vision models. And here's the fun part, that same Raspberry Pi controls my smart plug, which I built from scratch in a cave. So when I tell Jarvis or show the hand sign to turn on the lights, it literally powers a real circuit that I have designed. If you want more info about the circuit, stick till the end. My laptop's own camera is also part of the system. The AI can detect my hand, respond to gestures, and control the apps and other things that we can do with the laptop. So with this new part added, we can work with Blender like Tony Stark using 2 hands. The first model I made had only 1 hand detection. That didn't perform well because I was limited to only a few actions and instructions. Now with using 2 hands, we have more control, stability and workspace. Here's how it works. Our left hand is the mode selector and the right hand is the controller. If my math is right, the AI then takes the coordinates of the right hand and maps it out to the screens that we have. Now I can work with my laptop using Jarvis like Iron Man. It has its own flaws and it's not perfect, but like Tony Stark, we learn from our mistakes and we can improve it later on. Okay, enough talking. Let's get back to the lab and let me show you what this thing can really do. Welcome up, Daddy's home.
Welcome home, sir. I'll stand by while you review the design details from last night. Let me know if you need anything.
Let's say you're watching a YouTube video and you're working with your circuit and designing it, and you cannot really access the laptop that's like far away. So you can just take your hand and stop it with your hand.
Affirmative, sir. Dot.
And this is going to be 1.
Will do, sir. Toggling GPIO pin 36.
That light turned off. I have a device that is called M743. Can you search that?
Highlight using SPI for data transfer, ensuring clock speed compatibility, and employing level shifters for seamless AVR integration. Full details incoming. The structure of Smart Plug is simple. We have Arduino acting as a bridge between Raspberry Pi and relay modules. This step is necessary for safety since the relay modules have a coil that can have a voltage spike and burn the Pi 5. We have 8 relays for controlling 4 plugs. Power limit is quite good with 1000 watts per plug, but I've only tested up to 200 watts for 8 hours straight. That didn't burn anything and didn't explode, so I'm happy with the design that we have. And it was a success in my case. We can increase the power limit, but it means that we're gonna have more circuit and bulkier design. We can also add a ESP32 on the signal line so we can control the power over Wi-Fi. Later, we can use this structure and add more sensors and automation on top of it. Next video, I will dive deeper and make this amazing system even more complex. If you like the content, hit the subscribe and thanks for watching. See you in the next one.